Now, in day 2 of solving trig equations, we're going to get a little bit more complicated where we have to deal with multiple or partial angles. And again, we're still solving equations between 0 and 2 pi. Now, if we look at our example, you'll notice the difference today is that instead of it being 2 sine squared of x, it's 2x. This is an angle. This is an angle. So what that means is that when we get that sine squared 2x by itself, we're going to have to go around the circle twice. So let's solve this and then we'll revisit that. So we're going to add 1 to both sides. So we have 2 sine squared of 2x equals 1. Then we divide by 2. So we have sine squared of 2x equals 1/2. Then we square root both sides. So square root. So we have sine of 2x equals, well, we can't have the square root of 2 in the denominator. So 1 over the square root of 2 multiplied by the square root of 2 over square root of 2. So we have sine 2x equals the square root of 2 over 2. Now, yesterday, when we would get to this point, we would say, plus or minus because we took the square root. At this point, we would look and say, all right, when is sine equal to the square root of 2 over 2? And we would go around the circle. Now, because there is a 2 right here, the 2 in front of x means go around the circle twice. And then divide by 2 or multiply by 1/2. Because most of our angles are going to have a fraction already, it's probably easier just to multiply by 1/2 instead. So now that we've gotten to the end of that problem, all right, so instead of saying x equals, we're going to say 2x equals. Well, plus or minus the square root of 2, that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so that was one trip around the circle. Because, again, there's a 2 in front, we're going to make another trip around the circle. So 9 pi over 4, then 11 pi over 4, 13 pi over 4, and 15 pi over 4. So this one, right now, we have 8 solutions. Well, we have to get what x is equal to, so we're going to multiply, like I said, everything by 1/2. So multiply everything here by 1/2, which is just going to change the denominators of everything. So we have now pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. So the process is the exact same as what we did yesterday, except at the very end, we have to deal with that whatever number's in front of our angle. So now example B, we have sine squared 3x minus 2 sine 3x equals -1. And again, our angle here is 3x, which is going to mean we have to go around the circle 3 times. All right, so because this is in quadratic form, and you say, well, how do you know it's in quadratic form? I have sine squared of an angle minus sine to the first power of that same angle, and then I have a constant term. So I'm going to rewrite this by adding 1 to both sides. And like we've talked about before, we're going to factor that like it's a quadratic. Two numbers that multiply to positive 1 but add to negative 2, well, that's going to be negative 1 and negative 1. So sine squared of 3x minus 1 times sine, whoops, not sine squared, sine 3x minus 1 times sine 3x minus 1 equals 0. Well, they're the exact same factor. So we're only going to have one thing to worry about because they're both exactly the same. So sine of 3x minus 1 equals 0. Sine of 3x equals 1. So when is sine equal to 1? Sine is equal to 1 at pi over 2. But again, because there's a 3 in front, we need to go around 3 times. Go around the unit circle 3 times. So that was our first time around the unit circle. Have to go another time, so that's going to be 5 pi over 2. So all that work that we did with coterminal angles and getting common denominators in our head, that is super useful right here. Like, we don't have the time or the space to say, well, okay, how do I add 2 pi to that, get common denominators? We don't want to write all that out. We should be able to look at this and say, oh, pi over 2, if I add a full circle, which is 2 pi, that's really 4 pi over 2. So now I add 4 pi to get 5 pi over 2, add 4 more pi, we get 9 pi over 2. So now we have to multiply everything by 1/3. X is equal to pi over 6, 5 pi over 6, and 9 pi over 6, which is really 3 pi over 2. So this one only had 3 answers, while the other problem had 8. All right, now letter C. We have 2 sine squared 2x plus 2, equals 2 plus cosine 2x. Well, we have to have the same trig function, like I said, in most cases, except that one problem we had yesterday. This was one of those special cases where we thought and said, oh, okay, if both of these are exactly the same, then this equation works. This one's not really set up in that way because we have a sine squared and everything. So what I'm going to do is I'm going to change this to cosine squared. And the reason I'm changing sine squared into cosine squared is because I already have a cosine to the first power. We can't change cosine to the first power into sine to the first power. So 2 times sine squared is 1 minus cosine squared. So 1 minus cosine squared of 2x equals 2 plus cosine 2x. I'm going to distribute 2 minus 2 cosine 2x. Whoops, I didn't write down the plus 2x equals 2 plus cosine 2x. So now, just like the previous problem, I want to move everything over. So subtract 2 from both sides. Okay, these will cancel. And then I want my squared to be positive, so I'm actually going to add 2 cosine squared to both sides. So I get 2 cosine squared x plus cosine 2x equals 0. Right, then we can factor out a cosine, cosine 2x. We can factor out a cosine 2x as a GCF. And we're left with 2 cosine 2x plus 1 equals 0. So now we split this up. Cosine 2x equals 0, and 2 cosine 2x plus 1 equals 0. So this one, when does cosine equal 0? Well, cosine is equal to 0 at pi over 2 and 3 pi over 2. But again, because we are going around the circle twice, we have to go to 5 pi over 2 and 7 pi over 2. And then over here we have 2 cosine 2x equals -1. Then we have cosine 2x equals -1/2. So again, 2x is equal to, well, when is cosine equal to -1/2? That's 2 pi over 3, 4 pi over 3. But now we have to account for the 2. We go around the circle again. So we're going to add 6 pi over 3 to both of these. And then my final step for both of these, the one in black and in blue, is to multiply by 1/2. So over here, it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then for this part here, now when we multiply by 1/2, it is going to simplify some of the fractions. So I'm going to do those in my head. So 2 pi over 3 multiplied by 1/2, that'll be 2 pi over 6, which reduces to pi over 3. Then 4 pi over 3 would be 4 pi over 6, which reduces to 2 pi over 3. Then we have 8 pi over 6, which reduces to 4 pi over 3. And then we have 10 pi over 6, which reduces to 5 pi over 3. So these multiple angle problems, like these going around the circle multiple times, it isn't hard. It just creates a little bit more work that we have to be mindful of. All right, now letter D, again, we have to have the same trig function. So we're going to change secant into something with tangent because we can't go from tangent to the first power into secant. So secant squared is tangent squared x plus 1 plus tangent x equals 3. Now the first thing I notice is that we don't have a 2x or 3x. We don't have a multiple angle. So we're not going to have to do another pass around the unit circle. So subtract 3 from both sides, we get tangent of tangent squared x plus tangent x minus 2 equals 0. So then we factor that. Tangent x plus 2, tangent x minus 1, because positive 2 and negative 1 add up to positive 1 and multiply to negative 2. So then I have tangent x plus 2 equals 0 and tangent x minus 1 equals 0. Now, I'm going to do this right one first because there's something we have to do extra for the tangent x plus 2 equals 0. So on the right, we have tangent x minus 1 equals 0. Add 1 to both sides. Tangent is equal to 1. Well, what angles does that occur at? That occurs at pi over 4 in quadrant 1 and 5 pi over 4 in quadrant 3. Now over here, tangent x equals negative 2. Well, when does that happen? This is not on the unit circle. So use calc, but we have to be in radian mode. Now, when we do this, we're going to do the inverse tangent of negative 2. Well, because my angle is negative, that means I'm in quadrants 2 and quadrant 4 because that is when tangent is negative. So right here, Q2 and 4. So I'm going to have 2 answers. Now, when we do this in the calculator, it's only going to give us a reference angle, which then we need to okay, we are in radian mode, was that we need to put in the correct quadrants. So we get negative 1.107. So we want positive angles because that's what our restrictions say up here between 0 and 2 pi. So we need to put this in the correct quadrants. And it probably would be easier to look at a picture. So negative 1.107 would be down here. So then to get that positive angle, we would add 2 pi to it. So negative 1.107 plus 2 pi. That will give us one angle. So 5.176. But now we have to also get the angle in quadrant 3. Sorry, quadrant 2. So again, that is our reference angle. So if we want to go, if we want our angle to be in quadrant 2, okay, remember reference angle, we're going to have to do pi minus that. That will be in quadrant 2. So pi minus 1.107. Then we get 2.035 because we're going to round. So these two solutions are in conjunction with the two we had up here. So those are our solutions. So again, we only use the calculator when the angle is not on the unit circle. I would say 95% of the ones that we do, the angle will be on the unit circle. So we're going to skip problem E and go right to F. We have tangent 2x equals 0. So tangent is equal to 0 at 0 and at pi, but we have to go around the circle again, so it's going to be now 2 pi and then 3 pi. And then when we multiply everything by 1/2, x is going to equal to 0, pi over 2, 2 pi over 2, which is pi, and 3 pi over 2. And then letter G. Letter G, you notice we have 3 different trig functions: cosine, sine, and tangent. So let's start by first changing the tangent to sine over cosine, because then we're just dealing with 2 trig functions times sine 2x over cosine 2x equals 2. And then that gives us cosine 2x plus sine squared 2x over cosine 2x equals 2. I'm sorry, not 0, equals 2. Well, to add those fractions, we can multiply this first one by cosine 2x over cosine 2x. So then that's going to give us cosine squared 2x plus sine squared 2x over cosine 2x equals 2. Now on our identity sheet, it says that cosine squared plus sine squared equals 0 or equals 1. As long as the angles are exactly the same, that identity will always hold true. So even though it's cosine squared of 2x and plus sine squared of 2x, because those angles are exactly the same, that identity holds true. So we get 1 over cosine 2x equals 2. So then this becomes the secant of 2x equals 2. Well, now we can switch this to the cosine of 2x equals 1/2. So now when is cosine equal to 1/2? So 2x equals pi over 3, 5 pi over 3. And as we go around the circle again, that's going to be 7 pi over 3 and 11 pi over 3. And then again, multiplying everything by 1/2, x is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those algebra skills that we have been working on are crucial to be able to doing these problems quickly without a lot of space. All right, now our last problem, we have the tangent of x over 4. Oh, we haven't dealt with a partial angle. This is x over 4. So this x over 4 really means 1/4 times x. So instead of going around the circle multiple times, we're only going to go a quarter of the circle. So we're going to go a quarter around the unit circle, which means it's only in quadrant 1. So only quadrant 1. So when is tangent the square root of 3 over 3? Well, it's like that in, pi over 6. And yes, in quadrant 3, it is also equal to, the tangent is also equal to the square root of 3 over 3 at 7 pi over 6, but that's not in quadrant 1. So this is our only solution. Now we have to multiply both sides by 4, so we get x equals 4 pi over 6, which is 2 pi over 3. Right, so that's it for these more complicated ones where we have double angles and partial angles. So, like I said, the unit circle and your algebra skills are crucial for getting this down. So thanks for watching. Make sure to like the video and subscribe.